So in this video we are going to discuss trigonometric ratios up to transformations, page number 286, example 6. If ABC are angles of a triangle, then prove that sin square a by 2 plus sin square b by 2 minus sin square c by 2 is equal to 1 minus 2 cos a by 2 cos b by 2 into sin c by 2. So in the solution, given that ABC are angles in a triangle, so ABC are angles of a triangle. So when ABC are angles of a triangle, we know that sum of the angles is equal to 180 degrees. So A plus B plus C is equal to pi. And also what is given here, LHS. The LHS is given sin square A by 2, sin square A by 2 plus sin square B by 2. So minus sin square C by 2 is equal to, we have to prove that 1 minus cos A by 2 into cos B by 2 into sin C by 2. So now here what I am doing is, here we know that sin square theta is equal to, sin square theta is equal to 1 minus cos square theta. So using this identity, so what I am doing is, here sin square A by 2 is writing 1 minus cos square A by 2, and remaining two terms writing as sin square B by 2 is also as it is, and minus sin square C by 2 is also as it is. Now here, so one writing as it is, from these two taking minus common, this is minus of cos square A by 2 minus sin square B by 2 and minus sin square C by 2 is writing as it is. See, observe here, when you take the minus common from these two, so which is like, see, this is minus cos square A by 2 and minus into minus is plus, that remains same, and which is cos square A by 2, which is in the form of cos square A, minus sin square B. So for cos square A minus sin square B, we have the formula cos A plus B into cos A minus B. So we can apply this formula for this. So now here 1 minus, so cos A is A by 2, so that's why cos A plus B, that is A by 2 plus B by 2. So into cos A minus B, that is A by 2 minus B by 2. A by 2 minus B by 2, and minus sin square C by 2 is writing as it is. Now here, so we know that A plus B plus C is equal to pi, and also from this A by 2 plus B by 2 plus C by 2, when you divide by 2 on both sides, we get pi by 2. So from this you can write that, so A by 2 plus B by 2 is equal to 90 minus C by 2. So we can replace that A by 2 plus B by 2 is 90 minus C by 2. So that's why here A by 2 plus B by 2 is replaced by 1 minus cos of 90 minus C by 2 into cos of A by 2 minus B by 2 and minus sin square C by 2, writing as it is. Now here, which is in the form of like cos 90 minus theta, here cos 90 minus theta, we know that cos 90 minus theta is equal to, so sin theta, so here theta is C by 2, so that's why cos 90 minus theta is, we can write, so 1 minus sin C by 2 into cos of A by 2 minus B by 2, and here minus sin square C by 2 is writing as it is. See, observe here, 1 minus sin C by 2 into cos of A by 2 minus B by 2 minus sin square C by 2. So from these two terms clearly we can take the common. So minus sin C by 2. When you take minus sin C by 2 is common. One is writing as it is, and minus sin C by 2, if you take common here, cos of A by 2 minus B by 2, this is cos of A by 2 minus B by 2 is as it is, and here already taken minus sin C by 2 common, so that's why here we get plus sin C by 2 we get. So plus sine c by 2 we have. So now which is equal to, if you multiply here, so minus sine c by 2 into cos of a by 2 minus b by 2 is as it is. And minus into plus here, this is also minus sine c by 2 into sine c by 2 is sine square c by 2. Again here, so now c by 2 is also we can write from this c by 2 from the same condition. So 90 minus of a by 2 plus b by 2. So 90 minus of a by 2 plus actually minus a by 2 minus b by 2. So it becomes minus of a by 2 plus b by 2 is also we can write c by 2 is. So that's why wherever here sine of c by 2 is there inside the bracket. So that is replaced by 90 minus of, that means cos of a by 2 minus b by 2 and plus here sine 90 minus of a by 2 plus b by 2. So c by 2 is replaced by 90 minus of a by 2 plus b by 2. So then it becomes in the form of sine 90 minus theta. This is it. So sine 90 minus theta is, we know that, cos theta. So sine 90 minus theta is equal to cos theta. So here theta is a by 2 plus b by 2 is theta. So that's why here 1 minus sine c by 2 into cos of a by 2 minus b by 2, a by 2 minus b by 2 and plus here cos of this is a by 2 plus b by 2. So cos sine 90 minus theta is cos theta, theta is a by 2 plus b by 2. So now if you observe that this is we have one of the standard formula, that is cos a minus b, cos a minus b plus cos a plus b. It is like, so cos a minus b plus cos a plus b we have the formula. So 2 cos a cos b, 2 cos a cos b. So that's why which is equal to 1 minus sine c by 2 into this is 2 cos a by 2, a is a by 2 into b is b by 2. So that's why this is 2 cos a by 2 into cos b by 2. Finally we get 1 minus, if you multiply, so with sin c by 2, this is 2 into cos a by 2 into cos b by 2 into sin c by 2. See, observe that this is only the RHS we require to prove. So 1 minus 2 cos a by 2 into cos b by 2 into sin c by 2. So that's why ABC are angles of a triangle. Then we can prove that sin square a by 2 plus sin square b by 2 minus sin square c by 2 is equal to 1 minus 2 into cos a by 2 into cos b by 2 into sin c by 2. So therefore here clearly we can say that, so LHS is equal to RHS.